In this section, I'm going to introduce you to plotting points on the polar coordinate system. And up to this point, we've been plotting points on the rectangular coordinate plane, where you have axes x, which is your horizontal axis, and y, which is your vertical axes. Now we're going to plot it on a polar coordinate system, which looks like a bunch of rings. Polar coordinate starts with R, that's your radius, that's how far you're going to come out from the center, and then your angle, that's how far you're going to sweep open. So for point A, it says we're going to have a radius of 3, and we're going to swing open 315 degrees. So if you notice, 315 degrees is right here. I'm going to swing open until I get to 315 degrees, which is right here. And then I'm going to come out 3 units from the center. So 1, 2, 3. This is my point A. Now I'm going to erase this so that it doesn't get cluttered. Okay, for point B, it says we're going to swing open to 45 degrees and we're going to come out 2 units. So if I swing open, here's 45 degrees right here. I'm going to swing open 45 degrees and I'm going to come out 2 units. 1, 2. So that's my point B. Point C is given in radians, and it says we're going to swing open to pi, and this time we're going to go out in the negative direction, -2. Now this is a little bit different than what we're used to. When we look at the rectangular coordinate plane where we have x's and y's, we think going to the left would be negative or going down would be negative. But when you're looking at polar coordinates, negative is just going to be the opposite direction in which you're swinging open. So if I swing open to pi radians, coming out 1, 2 this way would be the point 2 pi. But -2 means I'm coming out in this direction 2 units. So this is going to be my point C. Okay, point D is I'm going to swing open -pi, and then I'm going to go out in the opposite direction, -1 unit. -pi means I'm going to be opening clockwise. So I'm going to open this way, pi radians, and then coming out this way 1 unit would be positive, but I'm going to come out this way for a -1, and that's going to give me my point D. Point E says we're going to swing open to pi over 2 and come out 3 units. So if I swing open to pi over 2, that's here, pi over 2, and I'm going to come out from the center 3 units. 1, 2, 3. So this point right here is my point E. Point F, I'm going to open pi over 3, and then I'm going to go in the opposite direction, -5. So I'm opening to pi over 3. Here's pi over 3. And if I come out from the center, 1, 2, 3, 4, 5, this way, that would be +5 pi over 3. But I need to come out this direction, the opposite direction, 5, to get my -5. So 1, 2, 3, 4, 5. This would be the point -5 pi over 3. So that's my point F. My next point is 5 and then -210. So I'm going to open up 210 degrees in the clockwise position. Now notice 210 degrees, if I came out in the positive direction, that's 30 degrees past 180. So I want to open up 180 degrees counterclockwise direction and then go another 30 degrees. So I'm opening up, I'm stopping here, that's -210 degrees. and then I want to go 5 in the positive direction. So 1, 2, 3, 4, 5. So this is my point G. If I was going in the negative direction, I would be coming out this way 5. 1, 2, 3, 4, 5. My last point, I'm going to go negative 11 pi over 12. That's pi over 12 shy of pi. So I'm going to go in the clockwise direction because this is negative, and then I'm going to come out 4 units. So I'm opening up pi over 12 shy of pi. I'm going to stop here, and then I'm going to come out 4 units. 1, 2, 3, 4. So this is my last point, point F. Okay, now that we know how to graph polar coordinates, we want to practice becoming familiar with polar coordinates by recognizing different ways to write down a point that is different from another point, but they still have the same location. This problem says we want to find a point that is the same as 5 pi over 4, in which r is positive, but the angle is between 2 pi and 4 pi. So we want the 5 to remain positive, but we want a different angle. And we want the angle to be between 2 pi and 4 pi. So if I graph the point 5 pi over 4, that means I open pi over 4, and then I come out 5 units. So this would be the point 5 and then pi over 4. If I rotate around again, and I add a whole nother rotation to that, my angle would be different, but I would still land in the same spot. So what I'm going to do is I'm going to take pi over 4 and add a full rotation to this. That way my angle will be different, and it will be an angle between 2 pi and 4 pi because it's on the second rotation, but it still lands in the same spot here if I come out 5 units. So I'm just going to add 2 pi to pi over 4. So I'm going to rewrite 2 pi as 8 pi over 4. So I have a common denominator, and I get 9 pi over 4. This is an angle that's between 2 pi and 4 pi. My r is positive, and it lands in the same spot as 5 pi over 4. So although these are written down in a different way, the location on the polar coordinate plane is the same. So for part B, it's very similar. We're going to open up 3 pi over 4. So I'm going to swing open to 3 pi over 4. That's this angle here. And I'm going to come out 10 units, and I'm going to have a point. So this is 10 units. We want to find a point that has the same location as 10 3 pi over 4, but we want r to be positive, and we want the angle to be between 2 pi and 4 pi. So that means I want to go around a whole nother rotation so that it lands in the same spot. It's at an angle between 2 pi and 4 pi, and my radius is positive. So I'm going to have 10 for my r, and I need to find my other angle. So I'm going to take 3 pi over 4, and I'm going to add 8 pi over 4, which is 2 pi, a whole nother rotation. And when I add that together, I'm going to get 11 pi over 4. And that is between 2 pi and 4 pi. And so we have this point here that has the same location as 10 and 3 pi over 4, but it's written differently. Okay, in example C, we have a point where we open up to an angle of pi over 4, and we come out 5 units. So this point right here is 5 and then pi over 4. Now, we want an r that is negative, and we want the angle to be on the first rotation between 0 and 2 pi. So what we want to do in this case, if we want r to be negative, I want to add pi so that I come out to this angle, And that way when I come out here and I go in the -5 direction, I'll still land in the same spot. So in order to get my r to be -5, I need to add pi instead of 2 pi. I want to add a half a rotation. So I'm going to take pi over 4 and add pi. So I need to come up with a common denominator, and I'm going to add 4 pi over 4, which is still pi, and that gives me 5 pi over 4. So my angle is going to be 5 pi over 4, and my radius is going to be -5. So that way, when I open up now to 5 pi over 4 and I go backwards this way, -5, I still land in that same spot. In example D, I'm going to open 3 pi over 4 and come out to 10. So this point here has a length of 10 from the origin, and this angle is 3 pi over 4. Now we want to find a point where r is negative and it opens up on the second rotation. So the angle needs to be between 2 pi and pi. We want r to be negative and we need to find a new angle. If I want my r to be negative and I want it to be in this spot, that means I have to stop here when I open up. That way I go backwards from the origin, -10, to land in the same spot here. But I also want it to be on the second rotation. So not only do I have to land here, but I have to land here on the second rotation. So I got to first find out what this angle is, and then add a whole nother 2 pi to that. So I'm going to take my 3 pi over 4, and I'm going to add pi so that I land here. And then I have to add another 2 pi in order to make it on the second rotation. So I have 3 pi over 4, and I'm adding 3 pi. I want a common denominator, so I'm going to make that 12 pi over 4. So that's going to give me 15 pi over 4 when I add them. So 15 pi over 4 is 3 pi plus another 3/4 pi. So if we start over and verify this, remember we want to land here. I'm going to open up 3 pi and then another 3/4 pi. So here's 1 pi, 2 pi, 3 pi, and then another 3/4 pi. So I swing open here, but now I come out to -10, which would be in this direction. So it works. I'm landing in the same spot I would land if I plotted the point 10 and 3 pi over 4. Okay, find a representative of 5 pi over 4 in which r is positive and it's opening up in the negative direction. It's from -2 pi to 0. So this is going on the first rotation, but in the negative direction. So if I plot this point, pi over 4 and 5, that means I have to open pi over 4 and come out 5 this way. So this is the point 5 pi over 4. But we want an r that is positive, and we want to open up in the negative direction on the first rotation. So that means I want to open up this way and come out 5. That would be if I take 2 pi and subtract pi over 4, because we open pi over 4 this way. So I'm going to take 2 pi and subtract pi over 4. So that's going to be 8 pi over 4 minus pi over 4 when I make a common denominator. And that's going to give me 7 pi over 4 in the negative direction. So if I open -7 pi over 4 this way and come out 5, I'm going to land in the same spot. So my angle should be -7 pi over 4. Okay, last example, example F. we have this point where we open up 3/4 pi and come out 10 units. So this is the point 10, 3 pi over 4. We want r to be positive, so we want this to stay positive 10, but we got to find an angle so that it opens up on the first rotation in the negative direction. So we've got to find this angle. So I'm going to take 2 pi and I'm going to subtract 3 pi over 4. So I'm going to rewrite 2 pi as 8 pi over 4. And that's going to give me 5 pi over 4. So if I open up 5 pi over 4 in the negative direction, I'm going to open up here and then come out 10 units, and I'll land in the same spot.